All right, kids, here we are. Next lesson on this incredible adventure, combine like terms. Now, most likely this is something that you should be relatively familiar with, but we're going to run through it and remind you of a couple of things. First off, what are like terms? Write this definition in your notes. They are terms that have the same variable and exponent. So some examples of like terms. You receive 3x and 4x. They have the same variable and exponent. They both have an exponent of 1. Talk about that. Again, 4x squared, 5x squared. Those are like terms. They both have an x squared term. Third example here. 3x squared y, 5x squared y. Same variables and exponents on those variables. This is an 2x's and a y, 2x's and a y, x squared y, x squared y. Those are considered like terms. These are not like terms. Write this in your notes. 3x and 3y. Variables matter. Coefficients don't matter for like terms. Same variables. Notice I didn't say anything about coefficients up here. I don't care if the big numbers are the same. Second counterexample. 3x, 4x squared. Not the same exponent. This is 3x. If you don't see an exponent, it's automatically 1. This is 4x squared. Not the same, not like terms. And then down here, I've got 6x squared y, 7xy squared. Not the same. This is 2x's and a y. This is 1x, 2 y's. Have to be exactly the same to be considered like terms. So, what do we do with like terms? By the way, if you didn't get this all down yet, pause the video, write it down, come back and catch up with me, all right? Number 1, when we say combine like terms, we're talking about adding and subtracting. That's what combine like terms means, all right? So if I've got, that's a 4, 3x plus 4x, I simply add them together. It is 7x. There you go. Add the coefficients. Number 2, first I need to identify the like terms. I've got 5x minus 6x. When you do this, especially early on while you're trying to remember, a couple things. One, single underline, double underline. I like that one. However, whatever method you use to identify these things, make sure you understand, and here's the big deal, you always use the sign in front of the number. Never use the sign behind the term. Always the sign in front. The plus here belongs with the 2y. The minus belongs to the 6x. The plus belongs to the 3y. Very, very, very important. Always use the sign in front of the term. Never behind. So I've got 5x. The plus is with the 2. Minus 6x. When I combine those two together, I get negative 1x. Yes, the 1 is optional. You don't have to write that. 2y plus 3y, 5y. Answer. Done. Those are not like terms. I cannot combine them together. That's it. That's all we got. Number 3. Anybody remember what this is called? Very good. Distribution. So, negative 4 times 3x. Watch your signs here whenever you're doing distributive, because that's a negative times a negative is plus 20. Watch your signs when you're distributing those negative numbers. All right, here we go. Number 4. Number 4. Take a look. Number 4, I want you to think to yourself, what is the first thing I'm going to do? Don't just think. Take a look. How many of you thought the first thing I was going to do was 4 minus 5? Raise your hand. Yeah. Stick your hand out there. Bad. No. All right. This is multiplication. It goes back to what we've been talking about. When you are distributing, you are multiplying. Multiplication's higher on the order of operations. I have got to distribute my negative 5 first. I am not doing this first. Order of operations is still in play here. So now, the 4 is untouched. When I distribute, 5 times 3x is minus 15x. Negative 5, negative 2, negative, negative gives me positive 10. That's my distribution. That's my first step. Now, I've got one more thing to do. I've got to combine those like terms because I see those like terms right there. It's a 4 plus 10. And minus 15x is untouched. Makes 14. One last thing to say to you. Remember, if you don't see a number in front of a variable, it's automatically a 1, 4x minus x, 3x. There you go. There you have it. There you are.